Imagine a shortcut through the cosmos itself, a tunnel connecting 2 points in space, allowing you to step from Earth and emerge near distant stars in seconds. This isn't science fiction. Physicists have the mathematical blueprint to construct such a passage. So, why haven't we built one? The answer reveals something profound about the universe's hidden architecture and why some doors are meant to stay closed. Today, we're examining one of theoretical physics' most elegant paradoxes. Wormholes exist in our equations, but the universe appears designed to prevent us from ever using them. Let's start with what we actually know. Einstein's field equations, the same mathematics that predicted black holes decades before we observed them, allow for structures called Einstein-Rosen bridges. These are genuine solutions to general relativity, not speculative add-ons. Here's how they work. Imagine space-time as a flexible surface. Normally, traveling between two distant points means following that surface across vast distances. But Einstein's math suggests you could fold space, creating a tunnel that connects far-separated regions directly. The mathematics is surprisingly straightforward. You need specific arrangements of mass and energy that curve space-time in precisely the right way. The equations don't just permit this, they practically provide a construction manual. But here's where theory meets reality's harsh limits. When physicists worked through the implications, they discovered something unsettling. Classical wormholes, those that emerge directly from Einstein's equations, are fundamentally unstable. The moment anything attempts to traverse them, the tunnel collapses. We're not talking about engineering challenges here. The collapse happens faster than light could travel through the passage. Even a single photon attempting to cross would trigger an immediate shutdown. But the problems run deeper than instability. Anyone unfortunate enough to approach a classical wormhole would encounter the same physics that make black holes so deadly. The gravitational forces would create what physicists call tidal effects. Your head and feet would experience dramatically different gravitational pulls, stretching you beyond any biological limit. Think about that for a moment. The universe gives us a theoretical pathway between stars, then makes it impossible to survive the journey. Recognizing these limitations, physicists developed a workaround: traversable wormholes. These would require a different approach, specifically a form of matter that could prop open the tunnel and make safe passage possible. This brings us to exotic matter. For a wormhole to remain stable and traversable, you need matter with negative energy density, not antimatter. Antimatter still has positive mass and energy. We're talking about something that violates our fundamental understanding of how energy and matter behave. This exotic matter would need to weigh less than nothing. It would fall upward rather than down. It exists in our equations, but appears to be forbidden by the deeper laws of physics. Even if we could somehow create this impossible substance, the quantities required are staggering. Current calculations suggest you would need exotic matter equivalent to the mass energy of Jupiter, all with negative density, just to create a wormhole large enough for a person to pass through. Here's a quick reality check. We've never observed exotic matter with negative energy density anywhere in the universe. Despite decades of theoretical work and experimental searches, this crucial ingredient remains purely mathematical. Some physicists suspect this isn't coincidence. There may be a cosmic censorship principle at work, a fundamental rule that prevents the universe from allowing paradoxes and causality violations. Traversable wormholes would enable time travel and could create logical contradictions that the universe seems determined to avoid. The evidence suggests our cosmos has built-in safeguards against its own most exotic possibilities. So where does this leave us? We have precise mathematical descriptions of wormholes, but every practical path toward building them leads to either certain death or impossible physics. It's as if the universe is simultaneously generous with theoretical possibilities and absolutely ruthless about their implementation. This pattern appears throughout physics. The equations reveal extraordinary phenomena: faster-than-light travel, time machines, perpetual motion. But the deeper structure of reality systematically blocks each one. Perhaps that's for the best. A universe where wormholes were easily constructed might be far more chaotic and dangerous than the one we inhabit. The cosmos offers us wonder through its mysteries, not necessarily through making those mysteries accessible. The most profound discoveries are the ones that teach us about limits, showing us not just what's possible, but what remains forever beyond our reach. What do you think? Are these barriers protecting us from ourselves? Or is there something we're missing about the fundamental nature of space and time? Let me know your thoughts. And if this kind of deep dive into physics mysteries interests you, consider subscribing for more explorations at the edge of human knowledge.